Hey guys, so today we're going to talk about 1.1. It's super easy. It's the easiest thing ever. So just follow along and fill in the notes and you'll be good to go. Okay? So yeah, it's really easy for you guys. So line of symmetry. We're talking about shapes in this whole unit, okay? So we're going to talk about symmetry, we're going to talk about rotation, transformation, and we're going to talk about surface area a lot, so which is 1.3, okay? So yeah, first of all, line symmetry has 5 characteristics, so let's write it down. I'm going to use the blue, just this one. Okay, so first of all, it means that it's a line that divides an object or design in half. Okay, so basically for this shape here, line of symmetry is in the center, so it divides the shape into two symmetrical or exactly same mirror image half. Okay, and this one, letter E, the line of symmetry is at the center, and this one for a diamond shape, so the line of symmetry is this and this. Okay, so it has 2 lines of symmetry, so it's rotated, it's oblique. So we are going to say that each side of the shape is a mirror image of each other. Okay, so they're mirror image, they're not exactly the same. So for example, this shape here, it's one of them is like this and the other is not like this. The other is not exactly the same in terms of rotation, but the shape is the same, of course, but it's a mirror image. Okay, so vertical, horizontal, or oblique. So basically you can have vertical line of symmetry and horizontal there we go, horizontal line of symmetry like this one here, and you can have oblique line of symmetry. Okay, so one shape can have a lot of different kinds of line of symmetry. Okay, so and it's also called, so aka line of reflection. Okay, and a figure that can have multiple lines of, like we said before, a figure can have, or shape, or a 3D design, an object can have multiple line of symmetry. So we're basically going to ask you how many lines of symmetry does this shape has, something like that. Lines of symmetry. Okay, there we go. And let's talk about each question here. So for each part, use a different method to find line of symmetry. You don't have to actually use different method and stuff. Just look for where the line of symmetry is and just draw it. That's it, okay? And tell me what kind of symmetry line that is that. So horizontal, vertical, or oblique. So in this shape here, you can tell that there's a line of symmetry here at the center. So up and down, they are mirror image of each other, okay? And that's what we call a horizontal line of symmetry. Okay, and this one here, this one's interesting because it's a dumbbell shape. So it's actually having a lot of, not a lot, but multiple line of symmetry. So the first of all, you can see that it's the center. When you flip it over, it will overlap, okay? And if it's the horizontal one, when you flip it up or flip it down, you can see that the shapes overlap each other. So it has 2 sets of line of symmetry. So this is a vertical line of symmetry and this is a horizontal line of symmetry. Okay, great. So next one, number of line of symmetry, and in this shape here we can just sort it out here. The first line of symmetry is the center. When you flip it over, you can see that the shape overlaps, and so there's a corresponding one that's the same horizontal one. And I'm gonna change another shape or color, sorry. The other line of symmetry, is there anyone that can think about other lines of symmetry then? Yes, we can. How about this one here? That's also a line of symmetry. And also this one here. Okay, when you flip it over, it's the same. So this shape has 4 lines of symmetry. Okay, so one line is horizontal or vertical. okay? And there are two that are oblique. Okay, so use folding. So basically, if you can actually print it out, or on your workbook you cannot rip your workbook out, but if you actually if the shape is on a piece of paper, a loose piece of paper, you can actually fold to see whether the shape overlaps or not. Okay, so this is basically the same as that. I'm not rewriting it. Okay, how many lines of symmetry does each figure have? I want you to pause and do it yourself and come back to me once you're done. Okay, so this triangle here, you can see that the line of symmetry is at the middle. When you flip it over, it actually overlaps. Do you think it's a line of symmetry here? No, it does not have a symmetry line here, okay? Because when you fold it over, it's like this, it won't overlap. So it has only one line of symmetry, and that's horizontal. Okay, and the house, if you do horizontal one here, no, it won't overlap when you actually fold it. But how about in the center here? Yes, it's a mirror image of each other. So one line of symmetry, and that's vertical. Vertical. Okay, and the star here, oh, that's a trickier one. You can see that the center has one, and you know that there's a horizontal one when you flip it over, okay? And the oblique one, is there the oblique one? Let's say if you actually draw a line of symmetry here, does it overlap? Yes. If you draw a line of symmetry here, does it overlap? Yes, of course. So it has 4 lines of symmetry. 4 lines of symmetry, okay? So one of them is horizontal, and one of them is vertical, and 2 of them are oblique. Okay, numbers of line of symmetry for the smiley face. So if there is one in this horizontal line, does it work? No, it won't overlap. It will just be like that. Okay, so horizontal one does not work. How about a vertical one? Yeah, it's mirror image. Our face is actually not like our left face is not exactly the same copy as our right face. That's just biological features. But a printed smiley face like that, it's like we assume that left eye, there's a left eye and there's a right eye. We're always in symmetrical patterns. Okay. Okay, so one line of symmetry, and is a vertical one. Great. And next page. Complete the drawing. So basically you just complete the other half. Done. Okay, and this one as well, they might, so the reason why they ask you this is that they might ask you the coordinate of stuff. So I'm going to show you what that means later. Okay, so in this case, how do you do the flipping? So do you see that's 1, 2 and half? So this side you basically do 1, 2 and half. That's B. Okay, the second B. And C as well, 1, 2 and half. That's C. That's the second C, mirror image C. Okay, so you connect them and you're done. Okay, so let's see what do I mean by coordinates. So if, let's say, this is actually useless, you don't actually have to care about that, but let's say my coordinates are here. So this is my y-axis and this is my x-axis. Okay, and then this is 0, so 1, 2, 3, 4, 5, 6, 7, 8. Let's say if it's like this. And then they might ask you, what is the coordinate of C? Okay, so basically this is 1, 2, and 3. So C for X is at 8. Okay, C for Y, that side is at 2.5. So 8, 2.5. That would be C's coordinate. So they might ask you, what is the second C? What's the other side C's coordinate? So the only thing that's changing, do you see that this C is still on 8 for X? Now what's changing is Y. So Y is going negative side instead of the positive side, okay? It's just a negative version of the original C. Okay, so it's like that, negative 2.5. So they might ask you something like that, okay? And this one here, same thing. You basically extend it and draw the mirror image, which is the H. Okay, done. Same thing. If they ask you coordinate, then you just tell them the coordinate, because it's either X is flipped or Y is flipped. Okay. All right, in this case, just draw it out. You don't want to just start with the line. You start with the point. Start with points and connect the lines. Okay, the points in this case, let's call it A. Now the other side's A, so A, what's it called? What is this thing called? I don't know. Okay, but yeah, it's the second A. A2, for example, is that. And this is, if this is B, 1, 2, 3, B2, and this one, let's say it's C, so it's 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So C is right here. Okay, and D and E, so 3. Okay, you locate all the points and then you just connect them. I'm gonna use my ruler tool. It will give me straight line in this case. There, you just connect them and you are good to go. Okay, yeah, done with that one. Again, if they ask you about coordinates, for example, let's do one example. If this is the y-axis, why is this shifted? Let's say this is the y-axis. Ooh. And then this is the x-axis. Okay, now what's A's coordinate? The original A's coordinate. So 1, 2, 3. This is 1, 2, 3, 4, 5. Okay, so for x is 3, y is 5. Okay, for second A, it's -3. In this case, -1, -2, -3. -3 and 5. Okay, so the only difference is that the x is now flip side of each other. Okay, and this one here, you find the points too, first of all. Okay, you find the points too. In this case, how do you find the points then? In this case, let's say this is A, B, C. Now, the only thing, because A and C is actually on this line of symmetry, you just start off with the same points. And how do you find B though? For me, I won't go like, okay, I won't go diagonally and locate where B is. I will actually go rise over run kind of method. So basically, I do from A to B, I went vertically, I went 1, 2, 3, 4, 5, 6. And horizontally, I went 1, 2, 3, 4, 5, 6, 7. Okay, steps. So same thing here. I want to do, for example, for on the other side, since you went up, now this time you're going down. Okay, you're going down 6. 1, 2, 3, 4, 5, 6. Okay, and you went right, so this time you go left. 7. 1, 2, 3, 4, 5, 6, 7. Okay, that's my second B there, and then you connect the lines. There we go. Okay, so basically in this case, because it's like slanted, it's not actually upward like horizontal and vertical, because it's oblique direction. So you just basically you do the rise over run thing and locate where that point is. Okay, yeah, so these are the homework. Finish them. Chapter 1.1 is pretty easy, so just I don't assume that you have any questions, but if you do, I will post on Google Classroom. Is there any questions? Collect all your questions and make a video of explanation. Okay.